Right, now we're going to talk about what is resistance. Now there are two formulas for resistance. One is V divided by I, so we define it as ratio of PD to current. Another one will be your formula for resistance in terms of length of the conductor and the area of the conductor. So let's first talk about the first one, R equals to V divided by I. Now, from this formula of R equals to V divided by I, we call it ratio of PD to current. Now, you notice in physics, whenever you divide two quantities, the way you define them is a bit weird. Sometimes you call it like ratio, sometimes you call it like per unit, sometimes you call it like rate of change, For example, if we talk about density, we talk about mass per unit volume, right? So you divide by these two, then how for resistance, you don't call it voltage per unit current? What you call it ratio of PD to current? Right? Or why don't you call density as ratio of mass to volume? Right? Is there a difference? And if you go on to like for example acceleration, you define it as rate of change of velocity. So why you got the change coming about? Right? So what is the difference now? Each of these definitions have a meaning to it. For example, if you are using the definition of per unit, like mass per unit volume, that means you can find density by taking total mass over total volume. That's what per unit means. When you're using like rate of change of velocity, that means you must take the change in velocity by the time taken, change over time taken. When you do ratio of PD to current, you're taking single point. Okay, example. Especially the difference between these two is very confusing. Now, if let's say I have a graph of velocity versus time, which is a curve, and I want to find the acceleration at this point. So what you have to do to find acceleration, because the definition is rate of change of velocity, you have to take the change in velocity by time taken. So what do? We draw a tangent to the graph at that point, alright, and then we find the gradient. So we take delta V over delta T. That's how you find acceleration at the point. But if you use let's say resistance, so you're plotting PD versus current. So this is PD, okay, so better write down there, this is PD, this is velocity, don't confuse, this is velocity. Alright, now if I'm using PD versus current here, and now I have a graph which is also a curve, and I want to find the resistance at the point. How do I find the resistance? Now, if you were to draw a tangent and you find the gradient, you'll be wrong. You can't do that. Because when you talk about ratio, you're talking about single value or single value. So the correct way of finding resistance is to take the value of V here divided by the value of I here. That's it. No need to draw tangent, no need to find gradient. But some people say, wouldn't it be the same? That means if I take the ratio of this V to I, is it the same as the gradient? Will I get the same value? Okay, let me prove to you whether it's same or not. So what I will do now is I will show you, instead of drawing a tangent to the point, I will draw a line from the origin to this point. Okay, I draw a line from origin to this point. Now I'm going to find the gradient of this line. So how do I find the gradient of this line? I need 2 points, right? So let's call this point 0, 0, right? And this point will be IV, agreed? So the gradient of this line will be equals to V minus 0 over I minus 0. Isn't it the same as the ratio of V to I? So in other words, the ratio of V to I, which is the correct way of doing it, is to take this value over this value, right? It is also equals to the gradient of the line drawn from the origin, not the tangent. And if you look at this line drawn from the origin, does it have the same gradient as my tangent? No. Therefore, gradient of my tangent is wrong. I cannot use it to find resistance. I must draw a line from origin to that point. Then some people ask me, why would I want to do such a foolish thing? If I can just read these two values, why would I draw a line from origin and find the gradient? Now, this technique is useful if you want to interpret the change in resistance. Example, as the current increases, there's this graph like this. So does it mean that the resistance of this conductor or whatever component is this, does it mean that the resistance is increasing or decreasing? Now, some people, if I ask them, what do you think, if the graph curves like that, does the resistance increase or decrease? And then what they do, they go put imaginary values here, imaginary value, try and error. You don't have to do that. The technique is, you write down the formula for the gradient here. Now the gradient here, I'm referring to the gradient of the line drawn from origin, never gradient of tangent. So the gradient of the line drawn from origin is V divided by I, right? Which is resistance. So if I imagine drawing multiple lines, that means if I want to figure out how the resistance changes along this graph, I will draw lines from the origin to the points here and see how the gradient changes, not how the tangent changes. The gradient of line from the origin. So you notice that the gradient here getting steeper or less steep?
Less steep.
Less steep. So if the gradient is getting smaller, the resistance must be getting
Greater.
smaller.
Or
Because the gradient represents resistance. You see that? Now if I reverse the axis, that means let's say I plot the graph of I versus V, which is more common, because usually what the people will do is they will change the voltage and find the current. So usually the voltage is an independent variable. So let's say I have a curve this way, alright, and I want to figure out how the resistance is changing here. So I write down the expression for the gradient. What's the expression for the gradient? I over V. Now I'm talking about what? I'm not talking about the tangent. I'm drawing a line from the origin to every point here. It's always line from origin. And the gradient I over V gives me 1 over R right now, because V over I is R, so I over V is 1 over R. So is my gradient increasing or decreasing?
decreasing.
Decreasing. So if the gradient is decreasing, that means my resistance is
Increasing.
increasing. So I can predict or actually interpret the graph as the resistance is increasing when the voltage is increasing. Okay?